talking about properties of logarithms. All right. Just like with exponentials, how they had their own rules that you followed when it came to simplifying. Logarithms also have those properties. So you guys are going to be able to expand and condense logarithms using these different properties that we're going to talk about today. Okay, there's three different ones. There's product, there's quotient, and then there's power. All right. So let's start off with our product property. The product property basically states that for any positive numbers, m and n, where b cannot equal 1, the product property states that when you have two numbers or two variables that are being connected through what operation? What's connecting m and n together? Multiplication. That you can expand this by using addition. So these two are the same thing. Log base b of m times n is the same thing as saying log base b of m plus log base b of n. This is used when you're solving logarithmic functions, simplifying logarithmic functions, expanding or condensing logarithmic functions, okay? It also works the other way. When you have addition, you can condense this into one log using multiplication, okay? Now, this also applies with another special type of logarithmic function that I want you guys to add in. It's called the natural log function, okay? Natural log is the opposite, is the inverse of a special type of exponential function, and that's the one that has an e. I don't know if you guys have seen this on your calculator or you've seen it in other math problems maybe at some point in time in your math life. No? You never seen anything like this?
That's just a number that that's the like that we use to make
Oh, you're talking about this e? Like you have e negative 4 at the end? No. Okay. Lord have mercy. All right. So, real quick, e is the number 2.7128, so on and so forth. It's a number that goes on and on forever, but it's a special type of exponential function. It's used a lot of times with compound interest, okay? It has a specific logarithmic function, which is ln. So anytime you see an e, you use ln. Log is used for any other type of exponential function, 2 to the x, 1/4 to the x, but this one goes specifically with e, okay? It too can apply the product property with it. So let's say I'm going to use two different letters because this already has an n. Let's say you had the ln of AB. Well, A and B represent two numbers or two variables. It too can be expanded by using addition. Okay? So I want you guys to write this in your notes as well. Now, if you're looking at the difference between log and ln, and you might notice ln doesn't have a base. It doesn't have to, because it only matches up with one exponential function, and that's e. Okay? Any questions on this? So the rule applies with log as well as ln. All right? So let's look at a few. We are going to condense these problems, 1 and 2, and we're going to expand 3 and 4. So anytime you see an addition, you know you can condense it using multiplication. So then it becomes just one log with a base of 3, and then you're going to multiply 7 and x together to get 7x. And that's it. Anytime you see addition, you can combine it with one log, and then you multiply the two numbers. Okay? So the next one would be log base 5 of 12, because technically it will be 4 times 3. 4 times 3 becomes 12. So far, so good? Okay. You can also use the same property to expand them, but you have to be able to recognize 5x is the same thing as saying 5 times x. So you can expand it using addition, and this becomes log base 4 of 5 plus log base 4 of x. Everybody see that? Does that make sense? Same thing here with this one. This is 36 times x. So then it'll become what? Very good. Now, sometimes when you're condensing, wait, I'm sorry. Give you guys a second to write that down. Are we good? Now, sometimes when you're condensing or sometimes when you're expanding, you'll get a log that you can actually evaluate, like this one. Log base 6 of 36 actually simplifies to be a number. 2. Remember, how do I write a log in exponential form? 6 to the x equals. So you're asking 6 to what power gives you 36, and that is. So this actually becomes 2 plus log base 6 of x. Okay? So if you can't go further, you go further. This is more likely to be used when we get to solving, which we'll do on Wednesday. All right? Questions? Now, these are some simple ones. Okay? Let's look at some harder ones. All right? On your desk, I want you guys to do, save B for me. Okay? I want you guys to do A, and I want you guys to do C. Okay? But save B for me. If you think you can do B, give it a whirl. But I want you guys to do A and C for sure. Okay, so what did you guys get for A?
Log 3 base 3 2 plus log base 3x plus log base 3y.
Very good. And then for C?
Log base 10 6x.
No. C. Log base 4. You know, it's so funny because all y'all always start like together, and then like when someone commands, like all y'all fall back, like all the way. Okay, so for this one, I forgot to talk about this last week, but whenever you have a log without a base, it's basically of a base 10. Okay, it's called your common logarithm. Now you don't have to write the 10. Okay, so whether you write or you don't write, it's still correct. But if you were to try to convert to exponential form, the 10 would need to be there. To expand this, you're going to need to factor. How does 36x squared minus 1 factor? And the thing that's keeping these two factors together is multiplication. So this can expand by saying log, you can put a 10, 6x minus 1 plus, and that is as far as you can go. As tempting as it may be to try to take that 6x and separate it, the 6x is attached to a minus 1. And you can't separate it because it has that minus 1 there. So then that's your final answer. Okay? Questions on product property? All right, let's move on to quotient. If product is addition, then quotient is subtraction. So whenever you have two numbers or two variables being divided, you can expand this by subtraction. So log base b of m minus log base b of n. This applies as well with the natural logarithms. Just remember there's no base needed whenever you have a natural logarithm. Okay? So we're going to look at a few of these. Yeah. All right. Alicia, let her see yours. I'm going to go to the next slide. All right. So Let's condense the first two. Let's expand the bottom two. So again, anytime you see subtraction, you condense it and it becomes log base 6 x over y. Anytime you condense, it always becomes one logarithm, not two separate ones, just one. What about this next one? 45 over 9. Can 45 over 9 simplify? What does that become? It's okay. It's Monday.
I thought it said 49.
Over 9? All right. And then to expand them, anytime you see division, you can expand it using subtraction. So this becomes log base 2 of x minus log base 2 of y. Okay? What about the one at the bottom? Very good. Log base 5 of 125 minus log base 5 of x. Can you simplify the first part? Is 5 raised to a particular number 125? 3. So this actually becomes 3 minus log base 5 of x. Because this whole expression of log base 5 of 125 does indeed turn into a 3. Because remember, technically no, because all I did ask you to do, like in something like this, I'll ask you to expand, and that is, the first line is the expanded form. But if it says expand and simplify, then it would need to be that bottom line. I think in your homework it just says expand or condense, so if you don't simplify all the way, then it's still right. Yeah. All right? Ready to try some on your desk? Okay. How is this going so far? You finished the paper? How you do the last one? Well, we're gonna do so. We're gonna like the lesson has the easy problems. The whiteboard practice is a little bit harder, and so your homework is like a mix between easy and hard. So it's in the middle. All right. So these you're doing on your own. So on your desk, you guys are doing these. And on that note, we're going to go over these problems, okay? Here we go. Division, again, means what? Division means what? Subtraction. So this turned into log base 5 of x, y minus 2. You can either leave it like this. You can put the y minus 2 in parentheses. Either one would work. Now, with B and C, they were slightly tricky. Okay? You have division, which means you should do what? So then this turns into log base 4 of A minus of BC. But the B and the C are connected together using, which means you can expand that some more. But this time you need to add, and you need to be careful because you're technically subtracting this second log. So you'll have log base 4 of A minus which means that if you wanted to keep going, you would have to do what with that negative on the outside? Distribute. Now, some of you guys did it automatically when you first started out this problem. You distributed the negative, but this is why it is a minus there. Now, if you leave it with the parentheses, that's fine too, but you could not have the second line without the parentheses. Does that make sense? Okay. Now, the last one. My suggestion to you, simplify this before you expand it. When you have a negative, And your exponent. Huh? Put it down to the bottom. So technically this becomes 5 over xy. And so then it pretty much turns into b. Okay? This becomes log base 2 of 5. xy. Okay, so be careful. Okay? Questions? All right, last one. Power property. Okay? With this one, to expand, and even though it might not look like you're actually expanding this, but anytime you have an exponent in the front of your log, you need to bring it, anytime you have an exponent, you need to bring it to the front of your log. So then it becomes n times log base b of m. Same thing applies with your natural logs. You bring that exponent to the front, and it turns into multiplication. That exponent times the log. Okay? And just as a heads up, this side is considered the condensed side. So if it says to condense and you have, like you're starting here, you would have to create the exponent. This is the expanded form. This one's always tricky for students when it comes to the condensing and the expanding part. So. Every time I hear that song, I always think of White Chicks. All right, ready? So, condense. Anytime there's a coefficient in the front, it needs to move to the back, and it turns into an exponent. So then it becomes log base 8 of x squared. Anytime there's a number in front, you need to bring it to the back and put it as a, so this is log base 5 of x to the 1/3. That's it. To condense it. To expand, you go the other way. You have an exponent, so you have to bring it to the front. So this becomes 8. And then the 12 becomes, you can't simplify number 12. Log base 3 of 9 turns into 2. So this is actually 7 times 2, which is 14. Again, if I just ask you to expand, the top line is the answer. But if I ask you to expand and simplify, then it's the bottom answer. No, it would just be 14, period. I like this font. We're gonna do a little bit of whiteboard practice because I don't want you guys to get to home and be like, we didn't have any problems like this. You know how y'all are. Okay. All right, let's do a little bit of whiteboard practice with this. Okay. And then we're going to do a few more other problems that are similar to the ones that are on your homework, a happy medium between the easy and the hard. So in the middle, the mediums. Okay? Huh? No. All these problems are considered like harder problems. All the ones in the foldable are your easy problems. And then your homework's the happy medium between the two. The sad medium. All right, so you guys give these a whirl on your desk. Give these a whirl. Okay, so y'all said that A was easy. You're expanding A. So this just became what? 5 log. of x. Okay, yes, that was the easier one. Now with b, there's actually a little bit more you need to do to condense this, okay? To condense, I think everyone kind of knew that that 3 needed to do what? Move to the back and go to the what? To the exponent. But you guys, you got a lot going on with this. Not yet. Not, well, actually we could and then do something later. But back in unit 2, we talked about radicals and how to convert a radical to an exponent. Back in unit 2. This is definitely not the condensed form because you got a radical here. A radical means an x, you can rewrite it as an exponent. Now I helped Isabel out on this one because, you know, she asked me about this one. And I know she knows the answer because we went over it. Oh, I thought you had it. All right. So who remembers? How do you rewrite a radical as an exponent?
2/3 or 3/2. Writing like a fraction is an exponent.
It needs to write it as a fraction.
But since, oh wait, would it be 5/2?
It would be 5/2. So again, to review, I think the notation was this in your actual notes, okay? But anytime you have this, you can rewrite it as an exponent, a fraction exponent.
Is there already a 1 on the spot right there?
Here? That's a square root. So then it's going to be a 2. So then this turns into log base 4 of x to the 5 halves because it's already 5 on the inside. So it just turns into 5/2. And now you have a 3 on the outside. What do you do to those exponents? So this turns into log base 4 of 50. I got my whole variable. X 15/2. So it is 7.5, yes.
I tried to put the 3 where the 2 was, and I added the 3 and the 2 together, and I put x to the power of 5/5, which is 1. So I was like, log base 4x.
No. Okay.
I had the right idea.
I want to write it down.
Yeah, I would definitely write this one down in your notes, okay? So anytime you have a radical, okay, the root, so in this case it was a square root, can be written as a fraction exponent. Since the 5 was already on the inside with the x, it turned into 5/2. And that 3 that we brought to the back gets multiplied using the power of a power rule of exponents. And that is the fully condensed form of number b. I know what I mean. The letter b. Okay? We're going to need that same skill to do c because as you can see already, see what I did there? You got the cube root and you got the 5th root. Okay? We can actually rewrite that cube root to be what? X to the 1/3. And then what about the 5th root of y? Y to the 1/5. Okay? So I can do that first, and now I'm going to expand this. The reason why it's expansion is because you have this multiplication, which means you need to do what? Say again? Add. So this is a natural log, so it just gets, transferred to both pieces, and there's a 15 out front. That 2 gets transferred to both pieces. So this becomes 15 ln x to the 1/3 plus 15 ln y to the 1/5. Nope, because it's not fully expanded. Anytime you have an exponent, it's not expanded.
Oh, we have to move the exponent to the other side.
We got to move that exponent down to the front. And you're multiplying. So this is going to be 5 ln x
plus 3 ln y.
And that's your final answer. Anytime it's expansion, that means you have no exponents, no multiplications, No divisions. Okay? And anytime you're condensing, there's no additions, no subtractions, no coefficients. Questions? So you have the easier ones in your notes. We did some of the harder ones here on your whiteboards, okay, on your desk. We're going to do a few other ones that are like a happy medium. These are going to be ones similar to your homework. We won't do all, 20